Howdy, my name is Magan-Patel. I am a general engineer. In this project, I help with the design of the boat. I determine how the boat would look like, the mechanics behind it, and the dimensions for the calculation of the boat.
Hi, my name is Suhani Patel. My major is marine biology. The role I played was helping with the researching of the materials, how they would work together with each other, and the pricing. I also helped with the sketching of the boat.
Howdy, my name is Mauricio Garcia. My major is general engineering. The role I played in this project was putting together the video edits, voice over the project slides, ran theoretical tests for the model. I also helped with materials research.
Our goal in this project is to have a full functional boat that is able to sustain itself on water using Lego motor. We try to research a boat that can sail pretty fast and speed that makes reasonable speed. We also want to provide the best quality and looks. How? We just research, design, and video.
These are the materials that we would need to build the boat. And the total cost of all these materials would come out to be $92.91. The materials we were able to find were good quality materials with low pricing. Researching which materials work best in water, we came to a conclusion: XPS insulation foam has a low density that can help it float on water. Also, they can be easily flexed into a curved shape and cut by practically any tool. We plan to cut and stack them to gain a more 3D-like figure. The glue we used is a spray foam with a 3D print nozzle that allows an equal amount of glue to spread. The glue is low density and fills gaps for leftover holes. Because the boat itself was pretty light, the motor and the plywood added to the boat would give it enough weight to sail on the water. To ensure that there are no holes or gaps left, we place a layer of fiberglass around the boat. Fiberglassing the boat allows less friction, which is the drag of the water collision, and acts like a coat for water resistance. However, the polyester resin, which acts like a glue, is a strong chemical reaction where it eats through the foam. Using many layers of latex paint can create a barrier for the foam and the fiberglass.
This GIF below is a Lego design we use. The tube of the large motor we must provide to enough torque to push the water. The UV3 next to it is a tube motor for easy wire and waterproofing. Our boat is a trimatic boat design where the two hull sides are smaller and the main hull is larger. This helps construct the idea as a blueprint. We will not be able to achieve the exact curvature, but we can approximate it the best we could. Because of the complex feature, the angles to turn, and the curvature of the shape is hard to recreate in the software. We ended up looking at a pre-existing file made by someone else did a similar project as us. This is Fab's RC 3D printed file we used. We drilled the hole to get a close match to the axle of a Lego shape and glued it in.
Physics calculations. When an object is floating on water with no active forces on the object or the water, the sum of all forces is zero. The force of gravity acted on the object is the weight force, and the force of buoyancy is the normal force. Force of gravity is equal to the volume of the object times acceleration of g. Force of buoyancy is the volume object submerged in water times density of water times the acceleration. Both accelerations cancel, leaving this equation is below. Calculation buoyancy. The more surface area that touches the water, the more force will be required to counter it. The viscosity of the water depends on the surface area of the boat. If the boat floats in a body of liquid honey, power is needed to move the boat. However, the water's friction is very low, requiring less power.
In the design for the boat, we wanted a more modern, high-class feel where it would have characteristics of a yacht. The aerial view of the boat shows the tri-hulls of the boat at the front end. This design also benefits us in wind resistance, where the curvature helps the wind slip past the boat rather than pushing against it. It also benefits us in water resistance, where the base of the boat comes to a curvy point that helps break the surface tension of the water and lets it glide past the boat. The boat comes into two layers that breaks up into the base level and the top deck. The back also has a similar tri-hull design as the front. This is one of the key points in the design, where it portrays a more futuristic style and as well as a balance of the boat itself.
Conclusion. We were able to work together in the project to make a functional boat that is able to float and race with reasonable factors going against it. From the design to the materials, we think that these factors will help the boat overcome the resistance to the wind and water leakage.